Hello you guys. So what you're going to do today, we are beginning a new chapter. This is chapter 9, and the material that we're going to talk about in this lesson covers sections 9-1 and 9-2. We're going to pull pieces from both of those sections. And you were given a yellow sheet of paper and a green sheet of paper. The yellow sheet of paper that is titled, Is It a Quadratic? And the green sheet of paper called Parts of a Parabola. If you notice at the bottom of each of those pages, there is a dashed line or a dotted line at the bottom. On that line, you are going to fold the dashed line up, and then you're going to put glue on the on the back side of that folded piece, the little tiny piece, and you're going to glue that sideways in your journal on a brand new piece of paper, a fresh piece of paper. And then for each of the lines on the piece of paper underneath that first section of two rectangles where it says, what is it, quadratic function, and on that piece of paper you're going to fold it, and then in each of the two places fold it so that you're creating like a little mini foldable, I guess you could say, where you can lift up the title, Is It a Quadratic, and you can see all 6 of the boxes. You're going to do that with both pieces of paper. You're going to have those glued into your journal, and you're going to take notes in these on these 2 pieces of paper today. So you're going to need a book, and I'm going to be referencing to different pages in the textbook where you're going to find this information. So instead of me just telling you all the information and you taking notes based on what's on the screen, you are going to use a book to gather the information, and you are creating your own notes based on the examples and definitions that are in the book. So, starting with the yellow piece, is it a quadratic? Let's look at the first box. What is it? A quadratic function. So for this, you need to turn to page 590 in the textbook. So page 590, and you need to write down that definition. You're writing down the definition of what a quadratic function is. Okay? Make sure you include there the standard form of a quadratic function. Okay, so that's going to be your first box. Press pause after each of these and do them. Okay, the next box that we're going to talk about is over to the right, which is how we determine whether something is a quadratic based on a table. So for that, you're going to look at page 590 again, where it gives you an example of a table, like example 1. Helps you determine whether or not a table produces a quadratic. So look at that, and you will notice that the book talks about something called the second difference. So we find the difference between each of the values, and then we find the difference of those differences. And we see if our second difference has a constant difference or not. So you're going to want to write that example down in this box. So if you look at example 1, notice the first difference, on the right-hand side in the y values, it went -6. So 8 to 2 is subtracting 6. From 2 to 0, you subtract 2. From 0 to 2, you add 2. From 2 to 8, you add 6. So that would be finding the first difference. Now we take those differences and find the difference between them. So to get from -6 to -2, we add 4. To get from -2 to +2, we add 4. Finally, to get from +2 to +6, we add 4. So notice how that second difference in blue there is all +4. Look at the x values. In the x values, we simply find the change in those. So from -4 to -2, that's an adding, let's see here, that says add 2 each time. -4 to -2, add 2, -2 to 0, add 2. So that difference is all +2, but then in the y value, we have to have the y value the second difference. Okay? So, write that example down. Then, if you look at the next box, the what is it, a parabola, we want to know what is a parabola. This is a vocab word that we're going to be using a lot in the future. This is on page 591. I want you to draw a picture, write down the definition, draw the graph there of what a parabola is. It's just that U-shaped graph. We call that a parabola. Now the next box is how to determine if something is a quadratic from a list. So if you look at example 1A on page 591, page 591, example 1A. That is a list right there that you are going to determine whether or not that list would produce a quadratic function. Okay, so you need to find the second differences. You do it exactly like you would from a table. Okay, so you find the difference in the x only one time, and then find the difference in the y values twice, and see if that difference is constant or not. If it is constant, then it would be a quadratic. If it is not constant, if it changes, like if you add 2 and then you add 3 and then you add 2 again and add 2 again, since that adding 3 messed up the constant difference, that would not be a quadratic, okay? So there's an example from a list. Then when you look at your bottom two boxes, we have how to determine from a graph. This one, all you want to do is we determine whether something is a quadratic just by looking at the graph to see if it is a parabola. So anything that's U-shaped that would pass the vertical line test is going to be a quadratic. So this is a quadratic. Something that would not be a quadratic would be anything that is not U-shaped. For example, a line. That's linear, okay? So this is not a quadratic because it does not make that U shape. Last one on this page is how to determine from an equation. And there's an example of this on page 591, example C. Okay, so I want you to write that down and read about that example and determine how you find out whether an equation is an equation for a quadratic or not. Once you finish that, we're moving on to the green sheet of paper, which is called parts of a parabola. And most of these topics come from the next section. So in the first box there, what is the formula for what? For an axis of symmetry. Axis of symmetry is an important word that you will find the definition for that on page 600. So that's the first thing you're going to want to do is write down that definition on page 600. Then you're going to want to write down the formula. The formula can be found on page 601. Write down the formula for axis of symmetry. Draw pictures, maybe draw in that dashed line, which is the axis of symmetry. So you write down in that box what you think is important about the axis of symmetry. Also look at a couple of the examples so you can get a good idea of it. The next box I'm going to do is right underneath it, which is called what is the formula for a vertex. On page 601, if you look at page 601, there's a box in about the middle of the page that's green that says finding the vertex of a parabola. You need to write down steps 1 through 3 on page 601 for this box. Those will tell you the 3 steps you're going to take for finding the vertex of a parabola. Okay, going back up here to the top, minimum and maximum. This is on page 592. There's a box in the middle of the page that talks about this value, this A value. You're going to determine something about things being A being less than 0, A being greater than 0. Read about that in the box on page 592 and write down the important information. Last box, the second box here, says, how do you find the roots and the zeros? The roots and zeros of a function are found on page 599. There's a definition of a zero of a function up at towards the top of the page. Write that definition down. And then I want you to draw example 1 in this box here. There's 3 different examples, A, B, and C, that give you 3 different pictures of quadratics, and they talk about the zeros of the function. The zeros of the function are another word for roots, which is another word for like the x-intercept. It's where the parabola crosses the x-axis. So if you notice in examples A, B, and C, there's 3 different examples of different things that can occur referring to the zeros of a function. And that has to do with how many zeros a parabola has. So read example 1, understand that, and write down the important facts. The last 2 that we have to do refer to the direction that a parabola opens. So if you will look at page 592, example 3, A and B, if you look at those 2 things, that will talk to you about how we determine whether a parabola is going to open up, making the shape of a U, or if it's going to open down, almost making the shape of an N a little bit. So figure out how we can look at something and determine which way it's going to open. And then last but not least, we have domain and range. Now we've done domain and range before, you guys. But here we're going to really focus on domain and range with quadratics. So this is going to be on page 595. 595 numbers 35 through 38 just give you some good pictures of graphs if you're struggling for getting an idea of how to draw some graphs. Those are great problems to use just as examples to kind of put in your notes. This is page 595, numbers 35 through 38. But really, where it talks about domain and range is on page 593. That goes over with you how to write the domain and range if you cannot remember how we do it. So there's one big thing you need to take away from the domain. There's one line you can write regarding the domain of a quadratic. See if you can figure out what that is. Then the range is always going to be a little different depending on the quadratic. You will realize you'll kind of come up with this pattern where if there's a minimum, you always know that your range is going to be y is blank. And then if there's a maximum on your parabola, if there's a maximum, that would mean when the graph opens down, we know that y is always going to be what? Fill in the blank there. Okay? So you want to make sure before tomorrow that all of these little boxes have been filled in, guys, and then remember to fold on this dotted line right here. In red, this dotted line at the bottom of your page is where you're going to fold and glue into your journal, and then kind of fold your paper so that the title is showing at the very top and the rest is all folded underneath it. It's kind of hard to show without you actually being able to see me. But we'll help you in class tomorrow if you can't figure out exactly how it's supposed to be folded. But those are your notes for 9-1 and 9-2. See ya.